So here's some data from a problem in our textbook. We have 10 adults in our sample, and from the sample, each adult generated 4.54 pounds of waste with a standard deviation of 1.21 pounds per waste per person. And then the confidence level is 90%. What we'd like to do is create a confidence interval. So I'm going to do that, and what I'd like for you to do is I'd like for you to do that. So pause the video, take a moment, and let's check it. So I've done all the calculations for this problem, and since we have done those, we have here our confidence intervals. So what I want to do is just walk you through it and see if this is what you got. The first thing we need to do was use the confidence level to find the critical value, and I did that by using inverse T, but you could have used the table in the back of the book. In the back of the book you would have looked up 90% and 9 degrees of freedom. In the calculator you want the area to the left and 9 degrees of freedom. In any case, that'll give you the negative 1.833, and that could also be positive or negative for the positive side. Then you find the margin of error. There's the formula. There is everything in the right spot. The margin of error is plus or minus 0.7014. And then what you do is you add and subtract that to the sample mean. And so our 90% confidence interval ranges from 3.839 to 5.241 pounds. Now, what would change? What if we changed the sample size? For instance, what if we made the sample size 500? Well, then that would make this margin of error right here much smaller, and then the confidence interval would be much tighter. That's because you had a larger sample, so it's probably going to be somewhat more representative of the population. So, and that's essentially how you would do this. If you were to compare those results, you would say, well, the interval with the smaller sample size is larger, etc. So one other thing that I want to do is I want to talk about what would your conclusion be for this confidence interval. And the conclusion is, since our confidence level was 90%, is you would say, I am 90% confident that the interval, and then you would list the interval 3.8, I'll do it a little smaller numbers, round it a little bit, to 5.2 pounds. So each of those would have the label that the interval contains the true proportion of waste produced by adults in the population. And so it could be the population of a town or a city or the world. It just depends where it was from, the US, etc. So let's examine this conclusion really quickly. The first thing you are confident in is you are confident in the interval. Why? Because you use the 90% to actually create that interval. And then, what are you confident in the interval about? You're confident that the interval contains the true proportion of waste produced by adults in the population. Now, why? You're basically confident in the interval containing the true proportion, the of waste produced by adults in the population of the United States, let's say, that refers back to the original problem. All conclusions are written exactly in this way. The only thing that changes is the actual interval, the confidence level, and this last part in parentheses, what you are referring to that takes you back to the original problem. Okay, that's it for that part of this. So to finish up here, one of the things we'd like to do is we would like to do the one sample, call this the one sample t interval. And if you go to your calculator to stats, test, then you will find this at it looks like number 8, I think. Yes, it's number 8, and it's labeled as t interval. All right, the one sample refers to the fact that we take one sample of data, but this is a t interval. If you press that t interval, then these are the things you will see. You will see input, and that input comes from data or statistics. You will see list if it comes from data. If it comes from statistics, you'll see x bar, s of x, and this confidence level. And let me go back to data. If it's data, then you'll see the data. The input is data. You'll see list. Then you'll see what's the frequency of each list. Generally, we put 1, or the frequency, if it's 2-column list, will be in list 2. You'll need this confidence level. All right, and then finally at the end you calculate. So let's compare these two real quickly. All the problems we have done up to this point have been from statistics. Notice we have known the sample mean, the sample standard deviation, the sample size, and the confidence level. If you know those 4 things, then you can create an interval. Okay? And then you'll press calculate, and it'll just pop out the interval. You add the labels and the conclusion, and you're done. If it's from data, if this particular piece of information is from data, then your data is going to be in a list. So if it's just one set of data, for instance, like problem 21 on the homework, then you would enter those 12 piece numbers into list 1, and then your frequency would just be 1 in that case because all the 12 numbers were different. However, sometimes you'll get a list where maybe it's organized in a stem and leaf or a frequency table. In that case, if it was a frequency table, then you might list the frequencies in list 2. So you just have to make a decision there. Again, you'll put the confidence level, 90, 95%, whatever, and then finally you'll calculate just like you do on the other one. So the key thing you have to do on your problems is you have to pay attention to what kind of problem it is. Now the problem I just did was like problem 17 in your book, and what you wanted to do in that case was use the stat menu, and it would give you exactly the numbers we got. If you have data, for instance like problem 21, then you want to put the data into the list, tell it what the frequency and confidence level is, and the calculator will then go ahead and figure all these things out for us and then give us the interval. So it'll actually list those things when it lists the interval. So I'm not going to do that for you. I think you can handle it at this point. You're getting better at calculators. And so therefore you can finish the rest of section 6.2 at this point. All right. What I want you to talk to me about tomorrow, if I ask you a question, is the difference on the calculator between using data and statistics. So be able to explain that clearly tomorrow. I may ask you to write it down. Okay, talk to you later.